So now that we have looked at the parent functions, let's start changing a and b and see how that affects our graph. So if I change not a is still going to be 1, but I change b to 2, how is that going to affect the graph for a tangent? What's it going to affect?
The b.
Well, obviously, but what does b affect in terms of the graph? The period, right. So, yeah, and the asymptotes, you're right. The asymptotes are going to be the start and stop of each period, so it's going to affect how much space is between those asymptotes and where those asymptotes are. So let's take a look at that. A is still 1, but b is 2. So the first thing it affects is our period. That's how much space is in between the two asymptotes. The period is now pi over b, which is pi over 2. So it's actually shortened it by half. Then we find the vertical asymptotes, which for tangent have the formula x equals pi over negative 2b and positive pi over 2b. Remember, this is a tangent graph. Cotangent is the one that starts at 0. Tangent goes to negative pi over 2b and positive pi over 2b. So that means our asymptotes, and thus our table, the first one's going to be at negative pi over 4, and the other one is at positive pi over 4. And remember that with the asymptotes, you have to say x equals. Sometimes I may just ask you for the asymptotes. I may not ask you to actually graph it. Sometimes I'll let you stop after period and asymptote. Then we'll build the table. Our table will start at negative pi over 4. We'll skip 3 slots and end at positive pi over 4. What's halfway between? 0. Always with tangent. Yeah, 0. And then this would be pi over 8, and this would be negative pi over 8. Okay? This will be undefined. This will be undefined. If you're not sure, you can check it. But if you're pretty confident that you did your asymptotes correctly, you can just know that pattern. What's the middle point's y value? 0. Yeah, for tangent, 0, 0 is always the middle point. Goes through the origin right there. And then we just have to decide whether this is A, or negative A. So let's just talk about, I always like to look at this one because it's positive. That's in quadrant 1, right? So in quadrant 1, tangent is positive. So I know that should be a positive 1. And if that's a positive 1, the other one has to be negative 1. So that's how I figure them out. I don't exactly have them memorized, but I know enough about them that I can kind of get there. Then we will graph it. Pi over 4 is pretty small. Let's see. Let's put it right here. I know. I forgot. But that's okay. I'll just go back halfway between and put it in there. That's pi over 8. That's negative pi over 8. Is that okay? Yes? All right. So we are counting by 8s. You're right. That's 1/8, 2/8, and then if we wanted to keep going, it would be 3/8, 4/8, 5/8. Put your asymptotes on. Remember to use dashed or dotted lines. Then we'll graph it. 0, 0, pi over 8, positive 1, negative pi over 8, negative 1. So all it did was squeeze the asymptotes together. That's all. It didn't do anything else. And I'm just going to do 1 period. Are y'all okay with that?
Yeah.
Could you copy a second if you needed to? Yeah? Any questions about y equals tangent of 2x? Now on the next one I'm going to give you, it's going to have a different A and a different B. And I want you guys to try to get through the period, the asymptotes, and the table on your own before we start looking at it together. Ready? Y equals negative 3 tangent of 1/2 x. Be careful because the b is a fraction, right? And people don't divide by fractions well. So be really careful when you do this. I'll pause for you. Okay, so for this one we have a equals negative 3, and that's going to be a big deal because it's going to switch around where your 3 and negative 3 go in your table, so be careful about that. And b equals 1/2, And that means that the period is pi divided by b. And if I divide by 1/2, it's the same as multiplying by 2 over 1. So the period actually gets bigger and grows to 2 pi. Okay? Then we find your vertical asymptotes. And we memorize those as x equals negative pi over 2b, right? And positive pi over 2b. Negative pi over 2 times b and positive pi over 2 times b. So let's think this through. X equals, what's 2 times 1/2? 1. So negative pi over 1 and positive pi over 1. I'll tell you this, I don't know if it'll stick, but every little thing that will help you, you may want to jot it down. The asymptotes for tangent are always positive and negative half of the period. That's how I know them, if I've got them right. If the period was 2 pi, what's half of it? Pi. It splits it down the middle. It puts half of it on the positive, half of it on the negative. So the asymptotes are always positive and negative half of the period. So if I get ever bogged down in the fractions, that's what I think about. Then we draw the table. X, y, negative pi, positive pi. Okay, halfway between is 0, halfway between is half pi. What are these two?
Undefined.
They're undefined, yeah. This one's also undefined. And the middle one will be 0. Now here's the kicker. One of these will be 3 and one of these will be negative 3. That's what happens. Yeah, it gets all, sometimes. Yeah, yes, it flips it around. Usually the positive has the positive. But this time the positive is going to have the negative and the negative is going to have the positive. Because the A is negative. So it flips around what you think. So what would in quadrant 1 normally be positive, the negative 3 multiplies by it and makes it negative. That's when it comes in handy to memorize the pattern, which I'm going to insert a slide and show you in a minute. Okay? But you should be able to see it. This is asymptote, asymptote, 0. Over here it's undefined, undefined, 0. And this is negative A, regular A. So that's how it will always work. Negative A, regular A for tangent. It's a lot to memorize. You just have to take your time and try to figure it out. And if you get stuck, go off to the side and plug it in. Watch, you guys. This is the one I plug in if I get stuck. I go off to the side and I say, okay, y equals negative 3 times the tangent of 1/2 times what? Pi over 2? Okay. That's negative 3 times the tangent of pi over 4. Well, what's the tangent of pi over 4? What is the tangent of pi over 4? 1. And negative 3 times 1 is negative 3. If I get stuck, I will go off to the side and do that one. And that's really a good habit to get into. It's the easiest one to plug in and check, and then you can see if you got it right. So if we graph this one, the period has gotten larger. So now it actually goes out to negative pi and positive pi. Those are our asymptotes. Our center point is still 0, but these are negative half pi and positive half pi. Oh boy. This is 0, 0. You have to be really careful here. It has reversed itself and goes up to how many? 3. That's yuck. So it's going to be pretty steep in there. And there is what happens when you make the A value negative for a tangent. It actually spins it around and makes it look like a cotangent when A is negative. Any questions about those tangent graphs? Okay. Let's see what we have next. Let's look now at a cotangent function where A and B are not 1. We have y equals 1/2 cotangent of 2x. So we can see that A is positive 1/2 and B is positive 2. So let's talk about how that affects our period. Our period is pi over b. So it's actually going to be pi over 2. And our vertical asymptotes for cotangent graphs are always x equals 0 and x equals pi over b. Well, if you notice, pi over b is also the period, so some people just memorize it for cotangent. They are 0 and the period. So that's pretty easy. So there are our vertical asymptotes, and we can build our table from those. Starting at 0, skipping 3 stays this, and going to pi over 2. Before we even fill in the rest, we know that if these are asymptotes, this should be undefined, undefined, and 0. One of these should be 1/2, and the other should be -1/2, but we don't know which yet. Let's go fill the rest in. Halfway between here and here is pi over 4, and then pi over 8, so my scale is 1 pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. All right, so we just have to figure out which one of these. And I usually just look at the smallest. This is my smallest, positive pi over 8. And I come over here and say y equals 1/2 times the cotangent of 2 times pi over 8. So y equals 1/2 times the cotangent of what? Pi over 4. If you use the first one after 0, it should always collapse to pi over 4 for tangent and cotangent. What is the cotangent of pi over 4? 1, right? Tangent and cotangent are 1 at pi over 4. So that's 1/2 times 1. So that's how I know this is positive 1/2. So this will actually be a, and this one will be negative a. So that's the pattern there for cotangents. Do you guys mind if I don't draw that? You're okay? I mean, we've seen enough, and I've already told you that for your homework, if you only want to graph every other one, that's fine by me. So just remember that. It just takes a lot to draw it, and I know they all start to look alike anyway, right? I mean, because we're not on any like major scale, so you're just shrinking them or stretching them to fit the paper you have available, so it's not helping you a whole lot to draw. But would you recognize them and be able to match them? Like if I gave you a page and had graphs on it, you could match them back? Yes? Okay. So just make sure that you at least get through the table for everything, but you don't necessarily have to graph everything. Just try to do every other one. I'm going to pause, I'm going to insert a slide, and we are going to do a review of everything we've done, like a generic review. Everything we know about tangent, everything we know about cotangent. Okay, so right here we're going to take a minute, and we are going to do a quick review of all tangents and cotangents. So let's talk about y equals a tangent bx. Here's what's always true. The period equals what? Pi over b, right? And the vertical asymptotes equal x equals negative pi over 2b and positive pi over 2b. And we talked about that, and we said they actually equal half of the period each, right? Another way to think of it, your table will always look like this. We'll start at negative pi over 2b. It will end at positive pi over 2b. 0 will be in the middle, and these are the two that you'll fill in just by going in by halves. This will be undefined. This will be undefined. The middle will be 0. And here's where people get in trouble. One of these is a, and one of these is negative a. The first one after 0 is a, because that is the one that will occur in the first quadrant. This is a, this is opposite of a. Tangent's different from everybody. Usually A appears first. Tangent is the only one where A doesn't appear first and 0 doesn't appear first as you go from top to bottom. So be careful with tangents. It's messed up a lot. Here's what we know about cotangent. We know the period is still pi over b, but that the vertical asymptotes occur at x equals 0 and the period, which is pi over b. The tangent, the table for cotangent starts at 0, just like sine and cosine, goes to the period, just like sine and cosine. And then these are your halfway marks. You just have to go in and find those. There's no set for those. They could be anything. These two y values are undefined because they're your vertical asymptotes. The center, just like for tangent, is 0. Now, is this one a or is it negative a? It's always whatever a is. So depending on whether a is positive or negative, you know, it may be positive, may be negative, so be careful. So if a is negative 3, that's a negative 3, but if a is a positive 3, that's a positive 3. So be very careful about these a's and negative a's. And this one will be opposite of a. So that doesn't mean it'll be positive, it means it'll be whatever it is. If a is positive, it will be positive. If a is negative, it will be negative. And the same thing here. This is the opposite, because a negative negative would make a positive. So just be careful. If you're not sure, you guys, pick one of them, plug it in by hand, and check it on the unit circle. Do not mess those up. I will break right there, and we will look at a couple of more, so don't put your stuff away.